A wonderful morning to all. So I hope everyone is audible. Welcome to the workshop on 5G communication using MATLAB, day 2. On behalf of pantechelearning, I thank Panimalar Institute of Technology. Sorry for the disturbance. I thank the convener Dr. M.P. Chitra HOD ma'am of ECE department. I also thank Mr. M. Arun sir, assistant professor, ECE department. I also thank Mr. D. Gurupandi sir, assistant professor of ECE department. So during this pandemic period, everyone stay safe. So I hope during the last session we have seen completely till the comparison of ASK, FSK, PSK. So whenever we are working with each and every signal comparison, therefore we have to know each and every kinds of variations over there, like bit error ratio and sound to noise ratio. So that particular comparison only it is being done over all the functions. And we have also seen what are the requirements for 5G, and at the same time we have also seen some of the advantages what and all will be there once the 5G will be applied over here. And we have also seen a small simulation on that. So today we will be continuing that particular session with OFDM, and at the same time we will also go with the applications of some CRN networks. So like as per we have said, many of the 5G applications, it is nothing but it mostly comes under the these many kinds of situations like healthcare, cars, smart energy, education, smartphones, virtual reality, and smart homes. Why it is mostly applicable for all this kind of systems means in future, let it be within 1 year or 2 year, definitely everything will be converted into IoT. So definitely once everything is converted into IoT, everyone has to get a good speed of internet connectivity, and at the same time just a moment. Sorry for the interruption. So definitely once whenever we are working regarding towards the smartphones or smart homes, it should be interconnected towards the IoT. So for that, withstanding that network, we have to use some sort of higher frequency oriented bandwidth. So for that purpose only they have released that particular fifth generation, because whenever that 5G gets starts, it will be in the form of a relay connections. So from one relay to another relay, when we are moving, the network also will be stable over there. And based on that particular stable, therefore what we have to see means it must be completely in the form of the frequency analysis. So once the network is stable means therefore all the IoT monitoring or the discontinuity will be reduced, because whenever if there is a fluctuation inside the signal, the device will be discontinued over there, and due to that discontinuity some of the data losses will be affected, like many kinds of data losses. For example, it will, even though the controller will be counting each and every kind of device, but with the loss of that particular signal, it won't be able to upload the data into the system. So that will be the main cause of reason once the signal gets reduced over here. So therefore, with the help of 5G, the discontinuity also will be reduced over here, and therefore it can be interconnected with multiple systems. And the other one of the factor which we have previously discussed, that is nothing but more than 10,000 traffic devices can be interconnect. It is acceptable inside the 5G network, and 10 to 100 devices can be connected at the same time. So that is the main thing. So based on that particular kinds of variation only, here all the IoTs will be expanded with the help of the 5G network. Then what are the different spectrum? So the spectrum starts from the magnetic field and it ends with some of the radioactive sources. So like it starts from some around of 20 hertz, then 50 hertz, 3 kilohertz, 300 gigahertz, 3000 terahertz, 3000 extra hertz. So based on that particular different variations only, we will be able to communicate each and every kinds of function. So whatever the current thing which we are using, it completely comes under the 3 kilohertz to 300 gigahertz. Let it be the mobile phone, TV, radio broadcast, all kinds of functions. Then if you are going for some of the ultraviolet oriented products means definitely it comes under the 3000 terahertz. So in this particular way only each and every electromagnetic spectrum variations are being applied over there. Let it be the AC current or it may be the static electric current. So this kind of different spectrums only it is able to produce that power for transmitting the signals. Even electric is also a kind of signal only, which is commonly said as the flow of electrons. So that particular flow of electrons, it will be passing from one end to another end based on the particular frequency. So that particular frequency is nothing but 50 hertz. The same thing if you are going in DC means there is no kind of current and all, because it doesn't have any of the frequency. So therefore in that particular section the voltage only will be provided over there. So generally like this kind of same section only, if you are providing the rated frequency of power to your tower means it will be able to broadcast that particular range. But beyond a certain level we are not supposed to provide it due to many of the natural harmful defects, or it is also harmful for all the humans. So in that cases what we will be doing means we have to maintain the power frequency, and at the same time we also should monitor in a particular way. It should be expanded. So for example, initially with the help of a mobile phone we were able to call and SMS. Later on the same size of the mobile we are able to chat through internet or do any of the basic search in internet. Then later on some size has been increased, but they have initiated the touch feature with a high camera. Then later on, they have made it as a mini computer itself. So computer with a different OS, because the computer with Android OS only we can say it as our mobile. So in that particular way only we will be able to just check it over there, and just you analyze it. Let it be any kind of mobile. For all the mobiles, the starting voltage providing for charge purposes nothing but 3.3 volts, and now it is 5 volt. So they are not varying that particular voltage. Let it be any kind of mobile. Only the battery amps will be increased for the storage purpose. So like that only, here we have to provide the stabilized power, and with that particular stabilized power, the frequency should be enhanced over there. And from that only, now we are going to just change from 4G to 5G. So for that we have to know this electromagnetic spectrum in a good manner. What are the tech evolutions till 4G? What and all they have been distributed. So the world is around with the GSM called as TDMA, time domain multiplexes. Then comes with GPRS and Edge for 2.5G, and this is for the entire world. And finally WiMAX also is there. But in Japan they will be using PDC at first, which is known as 2G, which comes under the TDMA. Then for 3G, directly they have gone for WCDMA and HSPA. Normally Japans are good in technology developments, so they have directly gone into the 3G. Then finally US found that IDEN, and later on they have just moved on towards HSPA plus and LTE. So both Japan and US has been combined over there. The same thing is done by US with another kind of TDMA is IS-136. Maybe you guys might have heard, like 10 years back, 10 to 15 years back, if anyone is bringing phone from US or any other applied with HSPA plus LTE and LTE-A. So currently whatever we are using in our mobile, it is LTE, and many of the optical fibers also has been started to provide the 5G for internet alone. And OFDM, it is also a trial version in order to apply it for underwater communication, and at the same time water filling OFDM is also available. So similarly for underwater communication, the other application is Li-Fi. So in this way there are different levels of technical evolutions for each and every place, terrestrial or it may be underwater. So wherever if you want to just communicate, so beyond that only the system is being designed. So these are the bands that has been exploited for each and every technology, which starts from WCDMA and as well as ends with WiMAX, which is used in mobile equipment. So it starts from 8249 with 869 for uploading and downloading frequency range for WCDMA alone. Then comes with GSM with the 925 and 880. So 1710, 1805 for LTE. Then 1920 and 2110 for another WCDMA improvement. Can also be set as HSPA plus. Then comes with GSM bar WCDMA. Like what are the mobiles? Some previous years we were having two SIM mobiles, like one with 3G and another one with GSM. So that's that they are applying it over here. So for that the frequency will be this range. And similarly now whatever we are using, both the slots are like 4G. So in whichever slots if we put our SIM, therefore according to that the slot will be taken. Then comes with the TD-LTE and TD-SCDMA. So like 1880 to 1920, that will be the range, like uploading with downloading. So similarly it moves on for LTE, FDD-LTE, TD-LTE once again with upgraded one. Then comes with wireless LAN like Wi-Fi, Bluetooth. Then WiMAX, like portable kinds of WiMAX modem, and mobile hotspot. So that is only the other WiMAX for mobile equipment. So these are the different sets of bands that has been exploited for each and every kinds of sections. So this is just an analysis regarding in which and all the places the 4G, 3G and GSM that has been applied. Okay, so now let us start with OFDM. So before starting with OFDM, if anybody has any doubts regarding this, you can just post it in chat box. If anybody have any doubts, you can just post it in the chat box. Okay, so I hope there is no doubts regarding this. So OFDM is nothing but orthogonal frequency division multiplexing. So with the help of this, whatever the frequency we are dividing, it will be moving in the shape of orthogonal in 8 angles. So within that particular orthogonal only, we will be just multiplying this kind of signals and we will be just transmitting it through some sort of encoders and decoders. So what are that particular OFDM applications like? OFDM diagram we are going to see. Then intersymbol interference we will be applying, packet detection synchronization, and related some sort of projects like not like a project, how to apply that particular related works. So the basic concept of OFDM is nothing but we can take two examples over here. So definitely within a one truck we will be keeping one pipe in order to fill any kinds of data. Okay, so here the data is nothing but the water. So to fill that water we will be keeping one tap for one truck. So that is nothing but the wideband channel. So within that wideband channel, you will be able to access the channel, but the band whichever it has been exploited, it will be in a wide direction. The same thing if you go for a narrow band channel means here it will be like a spraying one, and within that spraying area, if you just place that particular truck means it will spray the water and it will fill the particular truck. So in that only particular, it doesn't have any of the desired shape, but definitely it will be able to reach everyone. So that is that multi-band channels, and whatever the signals you are sending, it will be traveling in a narrow way. So that particular narrow way only here it is called as orthogonal frequency. So what is the difference between FDM and OFDM? So definitely once whenever you have to go on that particular FDM means it is frequency division multiple access. For each and every frequency whatever we are sharing within the system, it will be definitely having a guard band. So that guard band is nothing but to prevent the signal to get be exploited in that particular kind of way. For example, whatever the signals we are sending through that particular section, so if it gets interfere between that previous frequency and this current frequency over here, definitely there will be collision over there. So with that help of collision, what the problem will be there means the data won't be correctly reached at the receiver end. So that's why only each and every frequency will be separated in the functions of guard band. So from that particular guard band only all the data will be transmitted. The same thing if you go for the orthogonal carriers means there is no guard band at all. All the signals will be mixed, and at the same time so none of the signals will be interfered over there, because each and every signal has their own ID with value, and based on that particular ID and value, therefore this particular subcarriers we will be able to apply it. So subcarriers are nothing but inside the signal carrier, inside the main carrier, so there will be other some sort of layers. So within that layers only the data will be transmitted, and hence the receiver will be able to receive that complete data over there. Signal distribution in OFDM. So since we have said that orthogonal direction, here we have to take 3 parameters, and therefore the signal will be traveling in 3 multiple axes. So those axes are like X for time, Y for amplitude, and Z for frequency. So based on that particular signal direct distribution will be done. Like we have to compare the time, frequency and amplitude at the same time. So amplitude, it must be always the constant, because whenever the 5G is meeting its rated kind of frequency or that particular amplitude means, then the signal is good in strength, and if it is able to segregate the particular datas or whatever the signals we are sending within the required time, then therefore both frequency and amplitude are good in their strength. So for that particular purpose only, here we have to maintain both frequency and amplitude. So therefore within the time we will be able to send the some sort of separated data that has been sent by the user. For example, if you take any of the file and you are uploading it in any of the Google Drive, or if you are sharing through the WhatsApp, so if your network speed is at in a good state or good signal strength, therefore even if it is a small image, it will be taking a span of second. The same thing if you are just applying with the help of a low signal internet means it takes around of 2 to 3 minutes to upload that particular file. Then after that, to receive a tick mark inside your WhatsApp also, it will take some time. So this is nothing but the response that has been provided by the signals over there based on the strength. And according to the amplitude and frequency strength, the time gap also gets increased over there. So that's the complete distribution done with the help of the OFDM. So either the frequency or the amplitude should be in a rated one. It can also be said as the both. If the both are in the rated level means, then your device will be working much faster for communication purpose. And this is nothing but the multipath fade. So the same thing whenever we are just communicating over there, if we have any of the interference over there, because if at one place that tower is being placed and in between you have two different paths, one is nothing but full of the forest which passes through the trees, and another thing is the strong building. So one is known as the secondary path, and other one is the same parallel the comes under the secondary path 2. So here we have declared the secondary paths for two variables over here. One is alpha 1 and another one is alpha k. So here this particular path can be said as the reflected multipath, and the other one is the faded path. So in between they will be passing the straight line which is assumed as a signal. So that tower should send the signal directly towards that particular car only. Since this is an orthogonal, so the reflected path will be hitting some sort of obstacles over there. So that obstacle, if it is a stronger one, therefore that particular frequency or whatever it is being passed from that, it will be reduced over there. And the same thing if it is like an natural kind of sections, that particular signal will be faded up. But even though the signal will be transmitted, and hence we will be able to receive that section over there. So inside this multipath, there are two types like Rassian fading and Rayleigh fading. So Rayleigh fading, it mostly comes under the loss condition, whereas Rassian fading, it comes under the non-loss condition. The guard interval, whatever we have to apply into each and every set of sections means we have to differentiate that particular different signal, then into reflection 1 and the last reflection. Finally, to sample the signal, we will be using the sampling window. So the guard intervals are nothing but it is a smaller range which help the number of signals to prevent from interfering. Okay. So therefore, how that particular OFDM is working? So general like all the signals only, but here whenever we are just implementing with hardware, we have to just check it with some sort of the hardware capability. So based on that particular hardware capability, we will be able to enhance the frequency over there. So like the modulation, then signal processing. So modulation is nothing but whatever the input we are providing towards the transmitter. So therefore the modulation like according to the device, it automatically modulates that complete signal. Then that particular signal should be converted from serial to parallel. So with the help of inverse fast Fourier transform, we will be converting that particular signals, and to the carrier we will be sending it the transformed signals over there. So once after the carrier is being taken, so from there the parallel to serial will be converted, and hence since we want to transmit it through wireless, therefore the digital data, because whatever we are nowadays transmitting inside the mobile, it completely comes under the digital, and from digital to analog it will be converted. So from there the channel will be reading all the analog data, and based on that particular analog data, the noise will be reduced over there. Sorry, the noise will be added. Since the wireless application is done, some of the noises will be there. So that particular noise, it can be commonly said as the wind or any other speaking. So like that kind of many interruptions will be there. So that noises also will be included within the channel whenever it is being transmitted. Then once again it will be converted from analog to digital. Okay, so it's not digital to analog, analog to digital. Then it once again converts from serial to parallel, and from there the carriers will be removed. After removing that particular carriers, we will be just applying the opposites of IFFT, which is known as fast Fourier transform. And finally that particular kind of section, it is once again converts from parallel to serial, so that the demodulation can be easily applied. So from that demodulation, therefore we will be able to receive the data whatever it has been sent by the transmitter. So therefore it is nothing but how a phone call or how the message is being worked in the form of OFDM. So for everything, this particular same block only we will be using it. So what will be that particular processing flow for the block diagram whichever we have seen. So the data coded for orthogonal frequency for transmitter. So this particular region starts for the transmitter, then IFFT will be applied. and from there the transmitted data will be converted into the channel frequency response. Then finally from the transmitter, the receiver will be receiving the signal, and from there the FFT will be applied. So the conversion will be taken, and finally it will be decoded and will be sent to the user. So this will be the processing flow for this particular block diagram. Okay. So now let us see the comparison of QAM. So here for the compression purpose, we are completely using that DWT and FFT for at the place of QAM4. So whenever you are just able to upload it, so here the main components are like we have to just load all the complete data that ever has been provided, and here for the channel estimations we will be using the FFT and discrete wavelet transform at the level of 2 and at the level of hair. So from that particular only the compressions will be taken, and now we are going to analyze the complete data over there. So this is for BER versus SNR for 4 level of QPSK. So this is nothing but a small performance analysis. So here only we have to create the DWT QPSK over there. So whenever I run this particular command, so here it is not able to take the random integer. So whatever the data we have been executed, it will be stored over there. I hope there is a issue with the communication toolbox. Okay, so then let us go with the signal analyzer inside the 5G. So inside this wireless waveform generator, we can apply with that 5G sections in the form of OFDM. So here we have taken this particular kind of simulation. So here I'm going to apply that OFDM only. So from this particular OFDM signal, this will be the FFT length, the guard bands, then prefix length. Just a moment, it has been changed into QAM. Okay, So from here, that number of OFDM symbols are nothing but around 100. So here we are keeping only one antennas for transmitting, and the number of frequency for that particular subcarriers are nothing but 10 lakhs. So that is a particular value that has been provided. So input time for that particular, yeah, okay. So there was some interruption in network, I hope. So here we will be able to change the input either in QAM as well as in PSK. So first let us do in QAM, then we can compare it with PSK over there. So the modulation order for QAM, it is 4, and the mapping is provided in gray datas, and the bit source, it is according to the user defined. So here I'm just taking it in the form of P9. So therefore the filtering configuration custom. So what and all the filters should be applied, the normal filters will be applying automatically over here. As a simulation, it is very easy for us. So now let us generate the data. So it requires minimum 1536 samples to analyze the signal over here. And now this is the subcarrier and that particular variation of the signals for QAM. The spectrum analyzer for QAM, and this will be the results. The sample rate, the time, as well as the bandwidth. So similarly, you can also just change into PSK, phase shift keying. So now you can see that particular the time rate and the sample rate has been changed over here. So let us note this once. 256 T 12 3 250 kilohertz. So once again let us go back to QAM. So inside the QAM as well as PSK, the data are almost same according to this particular kinds of analysis. So in this way only we will be able to simulate OFDM with our complete device. So how the OFDM will be able to work in WLAN, especially for wireless. The same data only. So this is for IEEE 802. And here you can see how the variation has been applied for wired as well as the wireless signal. Yes, the version I am using it is 2018B. So based on that particular data only, here we will be able to simulate each and every simulations over there. I'm not sure whether the 5G apps and all is enabled for 2016 version. You can check it in add-ons. If you have any doubts, you can just post it in the chat box. So if anyone have any doubts, you can just post it in chat box. Yeah, thank you so Lakshmi. Thanks for your wonderful feedback. Thank you, Anina Anthony. Yeah, the attendance link is posted inside the description box, so everyone can collect it from there. If you have any doubts, you can just post it in chat box. Just a moment. Actually, the attendance links are the previous one itself. The Google Forms are open. So from that particular Google Forms, you can fill all your data, and you guys will be receiving your certificates through email to your registered mail ID. So I hope everyone has enjoyed the session. So thanks to all participants, those who have provided this wonderful support, and I hope everyone has got some kind of basic knowledge over here. So thank you all.